All right, everybody, let's take a look at an example of finding the moment of inertia of a shape. And what I've got here is a rectangle with a height of 2a and a length of b, and then I've attached a semicircle to that. And what I want to find is the moment of inertia about this axis right here, which I'm going to call y prime, because that's not through the center of mass of either of these shapes, nor is it through the center of mass of the combined shape, right? Now the center of mass for the rectangle is going to be here, and the center of mass for the circle is going to be in there someplace as far as these distances are concerned, all right? So we're going to need the parallel axis theorem, which I've written down here again, and then we're going to need to find the moment of inertia of these shapes. So if I start off with the rectangle, I know that the moment of inertia through the center of mass of a rectangle is 1/12 hb squared, where h is the height and b is the base. Well, in my case, my height is 2a. All right, and so what I'm interested in is the moment of inertia. I'm just going to do the rectangles. Remember, this is an integral. And so if I just do the rectangle and I just do the semicircle, then in the end, I add those together. So if I do this just for the rectangle, and I'm going to stick with this terminology for a second. I'm going to get 1/12 hb cubed, because it's about the y-axis, plus the area, which is hb, times the distance squared, but this distance is b over 2 squared, right? The distance through the center of mass of the rectangle is going to be b over 2. I'll get to the 2a here in a little bit, but I want to do this in general. All right, so this is going to be through the y prime axis for a rectangle. And you can look this up, but I want to do it this way first. So I'm going to get 1/12 hb cubed plus, that's going to be 1/4 when I square it, b times b squared is b cubed. So I got a hb cubed, hb cubed. So I have 1/12 plus 1/4, but 1/4 is 3/12. So I have 1/12 plus 3/12, which is 4/12, right? That's 4/12. But that's just 1/3. And so this is equal to 1/3 hb cubed. And if you look in your charts in the book, you'll find that the moment of inertia about the end point of a rectangle is 1/3 hb cubed, okay? All right, and so now I'll put in the fact that I don't have h, I have 2a, and so y prime, this is just for the rectangle, is 1/3, whoops, 1/2 h, but h is 2a, and then b cubed. So there's the rectangle. I've got the rectangle done. Now I need to do the semicircle. All right, so for the semicircle, I go to the book, and it says, hey, the moment of inertia of a semicircle about the end is 1/8 pi r to the 4th. Well, that would be pretty nice, because then I would add in d would just be this distance b. So it would be a, the area of the semicircle, times b squared. It doesn't work that way, because y prime here is the moment of inertia about an axis on the edge. But the parallel axis theorem is very specific. Iy is the moment of inertia through the center of mass of the shape. It's not through any other axis, any other position. This has got to be, super important, this has got to be the center of mass of the shape we're interested in. And so I have to go around this y, and there's the equation. It's not very pleasant, is it? But there's the equation for the moment of inertia of a semicircle around the center of mass. And so some y prime, not this y prime, so I'm going to get rid of that, but this y prime is going to be pi over 8 minus 8 over 9 pi r to the 4th. That's the moment of inertia through the center of mass of the semicircle, plus a, but it's just a semicircle, that's pi r squared, but then over 2, because it's a semicircle, not a circle. So pi r squared over 2 times the distance. Well, the distance is b, that distance right there, plus the distance from the edge of the rectangle, right? So in other words, this distance in here. So that's going to be 4r over 3 pi. So plus 4r, but r, the radius, is going to be a, right? If this has a total length of 2a, then from here to here is 1a, and that's going to be the area no matter where I, or the radius rather, wherever I'm at. So 4a over 3 pi. And then I would square that. And so all of this will be equal to the moment of inertia of just the semicircle, just this part right here, from this y prime axis. And so the moment of inertia of the entire shape would be this, that's nice and easy, right? Plus this, much less easy. And I should actually change that to an a to the 4th, because that's the radius of our semicircle. All right, so there's an example. Just add this plus this. Don't even think about the algebra. That's done. And that would be the moment of inertia of this shape about that y prime axis. All right, cool example. If you have any questions on that, please leave them in the comments below. Thank you.